So every time we do this where there's actual lecture type time, I'll make sure that it's recorded and that it's on the cloud. You can always visit that later. Um, and so, but like I was saying, is that I haven't taught a course this large online before. And in fact, uh, the only course that I really taught fully online was in the spring. And that I tried to make it as much like, normal writing on the board and that kind of stuff as we possibly could. And it was to a bunch of PhD students. And the class was, how many do we have, Nick? 5 in that class? So three, and then like a couple, a couple of gapers were hanging out with us too. So in this case, what I've decided to do in general is to be online, because I know some people are going to be off campus all the time. Some people actually need to be asynchronous for a lot of the material, which I think is fine too. And then also, I wanted to try out this course using some smaller screencasts so that you guys can consume this anytime that you want. You can always play the videos, slow them down, speed them up, whatever you need. Okay. Today is going to be the exception to that. So we'll actually do some lecture-y type things. We'll open MATLAB. We'll take a look at it. Do some arithmetic in there just to get this under your fingers. So in terms of, and the reason why we're doing this is because I know some people need to be asynchronous. And then also, my wife is about to pop. Okay. I mean, like, so there's a little girl in there that is going to come it's not any moment. Like, I think we're talking 2 weeks. So the due date is January 28th. And so by doing this online, this gains me the flexibility of actually, engaging in a good way and being at home, and that way I can support my family and so forth. So really it's for selfish motives that we're online, even though I think it may end up being more work for me as a result. So as we're going through this, maybe 3 or 4 weeks in, I'll stop and I'll send you all a survey just to find out, what's working, what's not working. And really, I'm going to defer to y'all a whole lot in this, because you have sat through, experienced, endured, enjoyed lots of different online formats with lots of different online classes. So I hope by now you've got an idea about what works and what doesn't. So I am completely open to feedback on that. Okay, so nod your head if you heard me here. Please give me feedback on, like I said, what's working and what's not, and we'll adjust and make sure that this experience is what it needs to be for you. So my next question is, so this is applied programming with MATLAB. I mean, this is the name of this course. This is what we're all about in this. Still show of hands, or is there another way to do this? There's probably another way to do it. Can you throw a high five or whatever? Do me a reaction. Throw up give me a thumbs up if you've ever used MATLAB before. And put up a heart if you just like are in love with it. Okay. All right, we got a few people that's use MATLAB. But in general, everyone here supposedly has had a procedural programming course, right? Give me a thumbs up if that's the case. Yes. All right, throw that thing up there. All right. And give me a heart if you were way into that. All right, we got some hearts. What's the other symbols here? Oh, hey, give me the laughter. The laughter if you were way not into that. All right. Okay, so we got some of that. All right, so real quick, I just want to know, who's had programming experience, who hasn't. Most of you have had it in some form or fashion. In your procedural programming, you were probably using C++. Okay, we have lots of different options for doing numerical computing. Okay, of course, this is going to be about MATLAB. That's what they told me to teach. That's what we're going to do. This is what I use the most of. But so you got MATLAB, C++, Java, Python is one I encourage you to become familiar with. Excellent open source program. Python, and then some more specialty type programs. Okay, R is one that comes up or will come up in data analysis, particularly those of you that are going to go to graduate school eventually. But you've just got lots and lots of options. Okay, And so just a quick explanation of why we would use MATLAB. Give it to me. Why do you think we would waste our time on a course called MATLAB, even though you've already have procedural programming?
From the on-ramp course, it seems like it's really nice for just doing a bunch of mathematical equations and modeling a lot of things for engineering and stuff.
Yes. So that's you nailed it, Beto. Is that with MATLAB, if we're going to compare that to C, C++, okay, MATLAB was actually written in C. Okay, so everything that we're going to do in MATLAB, its foundation is in C. So C, you can even think of it as powered by C. All right. And so in C, you're putting together your code. You're going to create an executable, right? You're going to compile your program. You're going to execute that. Okay. Same thing with Fortran. I actually took Fortran when I was an undergrad. Okay. And has anyone here had Fortran? Yeah, that's what I thought. And so, Fortran is what, well, I literally sent the astronauts to the moon. Okay. And it was like a bunch of stacks of cards, and then you're punching the cards and that kind of thing. So pretty antiquated language, an amazingly powerful language. All right. C, C++, C Sharp, those have all really replaced that. But with MATLAB, a couple of reasons why you need MATLAB. Okay. Number one, it's just very pragmatic. You're going to have professors that are going to require it. Okay. So you're going to need to know it. And it's much better that you develop those chops here, okay, in this class where it's okay to make mistakes with MATLAB. Whereas when you move into controls or, fields or some other course like that, and then they want you to know your MATLAB, they want you to make the mistakes in those courses. Okay. So that's a really pragmatic reason, in case why we require it. But the reason why we require that here, as Beto pointed out, is that this really isn't a programming language, right? I just now said it was written on top of a programming language or written by a programming language. It's actually a user environment. And so, so if you are a hardcore developer, if you're going to become a software developer, you're going to be using Ruby, you're going to be using all these different really interesting languages. A developer, if they were in this course, they would say, all right, this is cute. MATLAB is really cute. This is not a real programming language. Okay. And to that, I would just say, okay, you can call it what you want. It's what we use in engineering. And the reason why is it's a user environment and we can do things fast in MATLAB. Okay. Today, we're just going to be using it like a calculator. But as you're going to see, we can write scripts really quickly, functions really quickly. We can test, we can pilot all kinds of things super fast. It's the primary language that I use in my research. I'm a biomechanics researcher. I should have introduced myself too. I should do that in a second. And what my students use as well, for that reason. And so you can develop and test things, okay, way fast. And if I back up just a little bit, I'm Dr. Bradley Davidson. Even though mine says test student, it's because I logged in through Canvas. I am the test student, I guess. I was looking at Canvas as you see it, and that's how it took me. I've been a professor here for 10 years. My background, so I'm a professor of mechanical engineering. My background is in civil engineering, engineering mechanics, and biomedical engineering. And so my research is in studying human movement. I'm also a dynamicist. And so those of you that are in mechanical engineering for sure will have me next quarter when in Dynamics 1, or really kind of a particle dynamics class, and then Dynamics 2. Okay. And so if you're in mechanical engineering, you're going to see a lot of me over the next few quarters. And really, I haven't taught the sophomore dynamic sequence in a while. I'm looking forward to doing that. So that should be a whole lot of fun. But I've been here for about 10 years. Man, I don't know what else you need to know about me. I enjoy MATLAB. I really like it. I didn't see it until graduate school. And when I was in graduate school, I really thought, where have you been? I mean, it was really helpful. I found that I could do so much with it. And then I also dabble in a lot of other languages. I'm not very proficient in a lot, but MATLAB is definitely the one that I have forte in. Yeah, anyway, it should be a pretty fun class. I enjoyed teaching it last year, and we'll improve on that. So let's jump into, I'm going to share my screen, and I want to jump into the syllabus and the schedule, just make sure we're all on the same page. And so today, what you're going to see is we're going to work our way through the syllabus. Can you all read this? Is this big enough? Good. Okay. If it's ever not big enough, let me know, because I can do all kinds of adjustments here. But so we're going to spend some time just on the course structure, expectations. We'll talk about weekly quizzes, these weekly performance assessments, and really what you need to get started. Okay. And then toward the end, I just want to walk through some basic introduction to the MATLAB interface online. So applied MATLAB programming. So a syllabus, I always see the syllabus, and you should do this as well. You should see the syllabus as a contract, okay? It's a contract between me and you. You do this, you'll get this out of it, okay? I promise that I will deliver these things, and you promise to participate. And then, of course, most of you are interested in a grade as this comes out, okay? And so as we walk through this, there's a bunch of prerequisites here. The way that I approach this course is to require prerequisites of having some sort of introduction to computer science or procedural programming, and that I want you to have some calculus too, okay? Which implies that you have taken calculus 1. If you've had linear algebra, great. Multivariable calculus. If you've had differential equations, even better, okay? Now that said, I'm not going to present any type of mathematical information that really gets beyond calculus 2. If so, we'll spend some time teaching that. But the reason why that's important is because the way that I want to approach this class is really looking at it from numerical methods. Okay, if we took a bunch of engineering problems, then the truth is most of you are at the sophomore level. Okay, you've had statics. A lot of you are in DC circuits right now, in circuits 1, maybe circuits 2 next quarter. A lot of you are in differential equations right now, and so it just wouldn't be fair to you if I started taking these examples from other courses in engineering, say, hey, great, here's a thermodynamics example. And so then that's really saying you need to learn some thermodynamics and you need to learn MATLAB at the same time, okay? But if you've had Calc 2 and you're familiar with integration, you've had Calc 1, differentiation, and you can do basic arithmetic, then you're gonna be fine with this, okay? So these are the prerequisites that are here, but still, if you know someone that is thinking about taking this course and they're not quite meeting the prereqs, have them contact me, and we can figure out how to make this work, okay? Because this really is a programming class where you got to know some math. And so then required materials, okay? This is the Applied Numerical Methods 4th edition book. This is, I think you can get this in the bookstore, and so it's got a bungee jumper on the front. And so this is a kind of a book. It's been around a long time. In fact, in my undergraduate, I had a book, which I still have, called Numerical Methods for Engineers, okay, written by the same author. Okay, so this guy's been around for a long time, Chopra. And it's a pretty good book. I do recommend that you buy the book. And the reason why is because we certainly aren't going to work our way through this entire book. So that's not the goal of the class. But what I found is that, through all of my engineering courses and my career, is that if I need to look up anything numerical, that's the reason why I still have this book. I'm not a hoarder at all, but I've opened up this numerical methods book a lot just to find out what's going on. Okay. And so whether it's senior design or any other courses in your undergraduate, I think you will find that you'll use it, particularly because we tend to be pretty software heavy. We tend to be numerical and computational heavy. Okay. So I do recommend that you pick it up. It'll be a good reference as you go. All right. Grab the ebook. That's a fine way to go. You can get that several different places. Okay. But then the second thing that you need to have are MATLAB, and release 2020B is the current version of that. Okay. So there's a startup guide that I emailed to you a couple weeks ago. I think I sent it out again last week. And then is also on the Canvas page, which let me go to the Canvas page. The MATLAB course startup guide. And this is going to be a PDF that just walks you. You need to set up a MathWorks account. You can do that using your du.edu email address. Follow those prompts and just download release 2020B. Okay. If you've got an older version of that, if at least on a Mac, it puts a parallel version on there, and you can just delete the other one that's on there. I'm not sure how it works on Windows. But the startup guide is going to get you everything you need in terms of the MATLAB program on your desktop, but then also this thing called MATLAB Fundamentals. And so you're going to find that MATLAB Fundamentals is going to work in parallel of how we do this course. And I've synced up the material. MATLAB Fundamentals it's about a 20-hour self-paced course. And in this MATLAB Fundamentals, it allows you to have MathWorks. You know, these guys are the experts. Teach you how to do MATLAB. Okay, and I'll have one caveat to that, is that it teaches you in an environment called live scripting. And whereas this course, we're going to focus primarily on creating normal scripts and functions and running those scripts and functions in the more native environment instead of live scripting. You're going to find that live scripting is really fantastic for a self-paced course like what they have. And I think it's really good. I just haven't seen it be as effective or as useful in the day-to-day programming experiences that either I or my students have. Okay, I don't know. I honestly don't know of a single person that programs in live scripting. And so that's why I want to be much more practical and kind of get you in the meat and potatoes of MATLAB. And so then the other thing that you're going to find is that on the MathWorks account, and this is what you want to do right now. I mean, even as we speak, is come up with MATLAB, go make a MathWorks account. And when you make a MathWorks account, using your du.edu email address, then you will have access to this thing called online MATLAB. Okay. So from my MATLAB account in MathWorks, there is MATLAB Online. You'll see that. MATLAB Online right here. And as you click on that, it'll open up your MATLAB Release 22. Okay, so if you haven't downloaded, it's not on your desktop, you can access this and I've started using this recently, messed around with it, and it's really, really helpful. Okay, there's some advanced things that you can do in linking up your drives. You've got a MATLAB drive for sharing and saving your scripts between your desktop and online, and certainly feel free to do all that. But I'm going to leave all my examples and coding that I do in front of you just in the browser window, so you can see that that's possible. All right. So let's go back to the syllabus. Oh, I should have started at the top here. We have 3 TAs for this course. It's Becca McCubbin. Becca, will you say hi so people can see you?
Hi.
Okay. There's Becca, and then Nick Nelson. Nick, say hey.
Hey, I'm here.
All right, and then Drake Taylor.
Hey, everybody.
All right, so there's Drake. So these are our 3 TAs, and they each have a strong MATLAB programming background. You can correct me if I'm wrong, you 3, but is live scripting a thing that you just love and use?
I've never heard of it.
I've never
Until
heard of it
this.
either.
Last year, I was a little
Okay,
upset
there
you
we go.
used it because I had never used it before.
Well, that's all changing there. There you got it from 3 experts that are in the trenches right now, either never heard of it, hate it, or okay. It's kind of an interesting thing. So that's one reason why we're going to avoid live scripting in terms of delivering this content. The second reason, main reason is because I just don't find it that useful. Okay. The second reason why we're not using live scripting is because when we do the weekly performance assessments, it doesn't feature live scripting. Okay, so you actually have to kind of go back to the, like I said, the meat and potatoes MATLAB. It's going to make you a better programmer by doing this. But then back to the fundamentals. Let me get to my MathWorks account. Let's see here. All right, so when you log on to MATLAB MathWorks, and you've got the MATLAB Online, okay, a MATLAB drive where you can store a lot of things. And then there's going to be a button over here called My Courses. And so when you click on that, there are lots of options. So this is something that I begged the university to purchase this. I don't know that I was influential in them buying it, but everyone has this for free. Okay. Last year, everyone that took this class had to drop $100 just to have the MATLAB fundamentals. The feedback was that it was worth it. Okay. I think that was a really good experience with them. But you can see that there are lots of courses here. I mean, everything from this MATLAB on-ramp, which I would encourage you to do that if you get in the fundamentals and it seems over your head. Go back to the MATLAB on-ramp. It's probably a 20-minute experience, maybe 30 minutes or so. Wait, is that right? No, it's probably more like an hour or so, where it's kind of, basic. It's walking you through some of the basics. But with the fundamentals, where is fundamentals? This is down in the core MATLAB settings here. So MATLAB fundamentals, it's a 20-hour course that is really well designed. Okay, and we all have access to that through the university's license of MATLAB, which is great. And then, as you can see, there are a lot more courses here. I mean, everything with finances to, I mean, you can see I started this teaching with MATLAB course and didn't finish it, so hopefully that doesn't reflect. But everything from machine learning, symbolic math, nonlinear equations, data visualization, data processing and visualization. I suspect that that's a pretty good course. But as we're working through this, and I'll hop over to the schedule. In our schedule, there's several different columns. The last column is the fundamentals pacing, and so I have essentially what I expect you to have done by each day, by each class period that we have. So by Wednesday, do your getting started and do your simple plotting and common modifications. Okay, and then by Thursday, get this done. By Friday, finish your accessing data and arrays. And each Friday, and this is where the GTAs come in, each Friday, you're going to mail your certificate or email a link of your certificate to the GTAs to show I've made it that far, and you will get credit for making it that far. Okay, so that's going to be a portion of our grade. So that's how fundamentals is going to interact in our course. And jumping around just a little bit here, but fundamentals is worth 50% of your grade. Okay, so if you just get this thing done, you get it done on time, then you've got half of your grade completely finished, right? So don't forget to do that. And you do have to finish it to pass the course. That's the other string that's attached to the MATLAB fundamentals. Okay, so if you don't finish the fundamentals, then you won't pass the course. And also, the reason why the fundamentals is helpful, I think, in this scenario is because the MATLAB fundamentals get you everything that you need to, if you want to do a certification exam, which they call the associate certification for MATLAB, and it's something that you can put on your resume. I don't think any of the students last year did that, so I haven't gotten any feedback on whether that's worth it or not. It's not cheap. I think it was $250 or so to take the certification exam. And so it sounds like something that could be useful if to be able to say, I have, it's a signal to say I've made it this far in MATLAB for employers that are going to require MATLAB. And a lot of startup companies do. They, like I said, they kind of live in MATLAB or Python. Let's see here. Things to see are, so for the out of class activities, like I said, I'll be posting some screencasts and videos. They shouldn't be longer than 15 minutes. There'll be occasionally be a handout that you can work through as well. We'll do some work by hand to work out some of these algorithms before and during your programming. And so all of that information will be there. Do that before you come to class. And the reason why is because when we're in class, I think our best use of this time is going to be working on the practice problems. Okay, so there'll be practice problems that are assigned with every single class that we have. And my goal here is just to take off a little bit, just to kind of have MATLAB in front of you all the time and just do little by little by little, so that by the time we're done with this quarter, you feel very proficient at it. And, just like in procedural programming with C, Oftentimes it's not the syntax that's the problem. You know, it's not that you don't understand the syntax. Often it's not that you don't understand the algorithm. It's not that you don't understand the process that you need to be doing, but putting it into MATLAB, okay, and getting that to work is going to be the challenge. So debugging is something that we'll be doing together every single class period. And so that way, if you learn the material outside of the class period, you know, let's say there'll be a class period or a lesson on plotting, okay, and that's great, okay, and you can follow along and do that. But then when it comes time to actually make a debugging, you know, plot with legend, with the right scales, with the right colors, with the right everything like that, it's really helpful to, you know, if we were meeting in person, you know, to have me and Drake and Becca and Nick literally over your shoulder, you know, saying, okay, where's your problem? Okay, take a look at line number 69. Okay, take a look at line number 120. Like that's where you really learn MATLAB. Okay, and I would argue you learn MATLAB when you're working on your own projects because you really, really, really want to find that out. Okay, but the debugging process is something that it just takes time and time and time and time to do it. So it's best if we're together. You know, I'll put those in air quotes. If we're together to be able to do that. So starting on Wednesday, there will be no content delivery there. It will be show me your code. All right, let's talk about this. Let's jump into some breakout rooms or whatever we need to do so we can share and work on each other's practice problems and be able to give each other feedback and how to just get these things, get this stuff to work. Okay, so it's really a class in troubleshooting that happens to be numerical methods using MATLAB. Okay, and so so that's what we're going to be doing on our Thursday, Friday, and Monday. Okay, those guys definitely optional attendance. Okay, on Wednesday, however, not this Wednesday, but starting next Wednesday, it's going to be mandatory attendance. So that means everyone will be here. We'll be using. Well, I heard about lockdown browser and all that kind of stuff, but you're going to have a quiz every Wednesday, and that's going to be using the MATLAB grader. Okay, and I'll talk more about that later. Okay, I'll actually post a video to use that. And so for that, that's where you'll be, you know, showing your debugging skills and how to write code. Okay, that's the goal. So those problems will be contained within the 50-minute class period that we have. And we'll all be on the screen. We won't be doing them together anymore. You'll be independent on that. Okay. Okay, so this kind of leads us to the practice problems that we have. These are supposed to be practice. Okay. There really is no benefit of going to Chegg or anything like that for two reasons. Number one is because they're not graded. Okay. I'm not going to grade these practice problems. Number two is that a lot of these problems have been modified in ways that I think are going to express or kind of get you to do what you need to do better than the problems in the book. And really the third reason is you know, I think Chopra is a pretty good author. I don't think he's that great of a programmer in an interesting, just to be honest with you. And the reason why is because when I look at the programming, you know, with some of the algorithms that are in the book and that kind of stuff, I want to rewrite them. I want to rewrite them so they're more understandable. Okay. And this is going to be another theme of this class is that when we're programming, when we're creating scripts, we actually have to create scripts that communicate something. Okay. It's not just a matter of getting the right answer, but it's more like writing a document, okay, that someone else could come behind you and they need to be able to edit it. Okay. And so I remember I grabbed a couple of the functions, you know, from Chopra. They were correct, of course. Okay. But when I'm reading through them and I'm struggling to understand them, okay, and what's happening, then yeah, that's a problem because that means that, you know, a lot of y'all are way smarter than me. I'm not going to, you know, beat around the bush on that, but most of y'all are probably not going to understand it either if I can't. And so that's another thing is I want you to take away from this class is to write understandable code. Okay. Because the days are gone in which you only do things by yourself. Okay. So if it's just you, fantastic, get it to work and then just get it to work. Okay. But now we live in a very collaborative environment. It's a really good thing. Okay. And you've got to be able to communicate. Someone has to be able to look at your code and know what the heck's going on. Right? No final exam in this class. Actually, it's a shortened period, you know, shortened quarter. We've got 9 weeks instead of 10. And so, but 50% on the WPAs and 50% on the fundamentals. Okay. So, And this, another thing that I want you to kind of experience here is that this is a supporting course. Okay. I want you to be sweating bullets over mechanics and materials, circuits 1, okay, and whatever other of those foundational courses that you have. I don't want you to sweat bullets over this course. That said, if you get behind, you will sweat bullets. Okay, I promise that you will. We saw it last year. Okay, don't take this course lightly, but know that I'm not trying to hurt you. Okay, all right. Before we get on to the schedule, what questions you got? Fantastic. All right. Silent audience. Okay, so the schedule is also on Canvas. And so we're going to go ahead and meet 4 times a week. Okay, I know it said recitation, but like I said, this is really kind of like extended office hours each time. So I want you to have access to all of these office hours. And then because I'm reworking the schedule, this isn't completely filled out yet. But you can see we're going to spend a little bit of time on just scripting and arithmetic. We'll get into custom functions. Okay, this is a really important part of the course in part 2. Part 3, we're going to focus only on visualization. Okay, you'll have some data sets, you'll be plotting things, just working to make that good. I've heard from other students that have taken this class, functions and visualization are the things that they really, are being required to perform in their future course. Okay. And then get into basic logic. This is going to feel a whole lot like your procedural programming class where we're doing if, then, while, and so forth. And then the last 2 parts where we're dealing with roots, and then in linear systems and matrices, this is really actually saying, all right, we've learned enough about MATLAB, we've learned enough about the functions, let's apply it to some interesting numerical problems. Okay, so those last, kind of week 6, 7, 8, and 9 is where you'll be learning new skills, probably some things you haven't ever actually thought about. And so that'll be some new information in the course, right? So let's jump into actually doing some MATLAB. So just follow along with me as we are, okay, I gotta get to MATLAB Online. So open up your MATLAB Online. That's not where I want. There we go. So go to your account and open up this MATLAB Online. So we are going to talk about 2 windows today. Okay, we got about 16 minutes left in this class. So the 2 windows that we're going to talk about here are going to be the workspace, okay, which in the native MATLAB is down and to your left, okay, and then the command window, which is this prompt here with the 2 arrows. And so again, right off the bat, you're going to start seeing differences between your classic programming, like C, C++, and MATLAB, because MATLAB gives you immediate feedback with what you're doing, right here. In the command window, I mean, this is just mathematical skills. This is trying out things. I don't want to jump right into scripting. And part of the reason is because when I'm scripting, I'm all the time going back and forth between scripting and command window to try out what I'm doing in the command window. And then I drop it into a script, which is your actual program that you're going to execute. And so you can reconfigure your windows in all kinds of different ways. I think pretty much everyone comes up with their own themes and their own, just depending on how you think. Okay. Most of the students in our research groups tend up, changing their colors and their fonts and all that kind of stuff too. So you've really got a lot of options. Okay. This really works a lot like a calculator. And so there's a document on Canvas, and I'm going to be posting these cheat sheets. Okay, so for every single lesson that we have. If there's something that you just kind of need to have at your fingertips, there'll be a cheat sheet. And if y'all can see this, these are normal operations. We work in our normal order of operations as well, of doing parenthesis, exponents, multiplication and division, and then addition and subtraction. Okay, this is just like we work it out, by hand. And so, if we put in something like, 5 to the 7th, okay, it gives us 78,125. Okay, I mean, so it's a calculator, it's kind of a big deal, great. But one of the nice things about MATLAB is that you can see what happened, or if you notice this here in your workspace, okay, your workspace is keeping up with how the memory is being used. Okay, now we often don't have to worry about, at least in this class, we shouldn't have to worry about memory issues like running out of memory, but we do want to know and always know what's in the memory to be able to be stored. Okay, so now when I typed in 5 to the 7th, okay, so just 5 caret 7, it popped up with an A and S. Okay, and so it's the answer. And then it stored a variable in the workspace called ANS. Okay, so anytime that you just generically type in some information, it's going to store it as ANS, right? So if I do 5 times 7 times 9 divided by 7, okay, I'm going to get 45, right? And so now it stored it as ANS. And so so you can always pop up. So if I type in ANS, it's going to give me that same answer again, right? So you can always recall these variables. And so you can start working with these different parentheses, different order of operations and so forth. This is what your practice problems are going to be, okay? Is using just the workspace as a calculator and what that looks like. Now, your workspace can get pretty cluttered, okay? When it gets cluttered, there's a command called CLC, okay? It's one that as you continue doing this clear command window, as you work in the workspace more, this is going to be something that just rolls off the tips of your fingers, okay, because you get used to typing it so much, right? Now notice that it cleared the workspace, okay, but it didn't clear, I'm sorry, forgive me, it cleared the command window, okay, but what's over in our workspace, right? We still have the variable ANS, okay, and it's still 45, that hasn't changed. And so in the workspace, you get a visual representation of what you have over here. Okay, when you get that grid, okay, that's indicating that it's a numeric variable and it has it's a double precision number. Okay, and you probably talked about that in your procedural programming course, what a double precision number is, what a floating point number is, what single precision is. Okay, that's not the focus of this class, so I'm not gonna bore you with those details. Okay, but essentially MATLAB, it stands for Matrix Laboratory. Okay, so when we have the the grid there, okay, that's indicating it's a matrix, and this matrix is a 1-by-1 matrix or a scalar. Okay, as we'll call it here. And so, so no matter what we type in, okay, it's gonna put it down there in the workspace, right? And then, but really when we're programming, we don't just want to just use a calculator, go line by line, okay? Because if, this would be a really expensive calculator. I mean, y'all have paid a whole lot of money to see a course on calculation, but we do want to start defining variables, okay? And so that's what our equal sign is all about, okay? So the equal sign is not an equal sign as we typically think about it, okay? But instead, it's an assignment operator, okay? And so, so if I type in x is equal to 15, then I have another variable space. I've got ANS, which is stated at 45, and then I've got x is equal to 15, and now I can use that now, right? So, so one of the things I can do is I can write over it, okay? So what's going to happen when I do this? And I've got x is equal to 3x minus 12, right? So as we're looking at our operations, I've got 3 times x, right? X is already equal to 15, right? So 3 times 15 is going to be 45. I'm going to subtract 12, and oop, that didn't work. I didn't do that the right way. Sorry about that. There we go. So I should get 33 out of that. It looks like what I did is I had it highlighted, and because I had it highlighted and I pressed enter, it only executed what I had highlighted. Does that make sense? And so here, x was equal to 15, and so it gives me 33. But now it's overwritten that. So it's always going to be overriding the memory when we use the same variables. Okay. And so this, 3x minus 12, it's different than, let me pull up a screen that we can write on. It's different than we had, just writing like from your algebra class, if we had x is equal to 3x minus 12, okay, because when we solve for this, we would, do the same thing to both sides, right? So we get x minus 3x is equal to negative 12, and then we get negative 2x is equal to negative 12, and then x is equal to 6, right? And so do you see the difference between use equal sign as an equal sign, like in algebra, versus the equal sign as an assignment operator in memory allocation? Okay, and that's an important distinction to make. Okay, and as you experience more programs, they have different ways of doing the assignment operator. Okay, in MATLAB, it happens to be the equal sign, which is the same as C when you use that. So, so another thing, okay, and I'll clear my workspace. I'm sorry, clear my command window. But if we do want to clear our workspace, okay, it wouldn't be CLC. We're just going to use the clear command. Okay. So clear then removes everything from the workspace. We start with a clean slate, and we can continue moving on. So a couple other handy commands when using the workspace or using scripts is the semicolon, and the semicolon is going to suppress rewriting that output that you have. And so if we have A is equal to 12, and then I have a capital B is equal to 4, and then I have C is equal to, let's say, A minus B plus 40, whoops, so 40, then we get 48, okay? And start working with the order of operations. You can see it's stored A, it's stored B, and then we calculated C. And we have A, B, and C in our memory, okay? But we didn't have to then go through, seeing all of these with the semicolon suppress the output each time, okay? So, so another thing is that, so these are numerical variables. We can definitely, have things that are character variables, okay, or strings. Okay, so we could write, I love you, MATLAB. Right, and you can see that in this, it's now popped up with a different symbol. Okay, so this is a character array or a string. Okay, and we can, and notice that the name of it is ANS, right? And it's ANS because we didn't assign it anything, right? But if we want, we could say, actually we can press the up arrow. The up arrow, you can see, gives me my other commands that have been there, right? And I just press the right arrow to get what I wanted. Move back to the beginning, and I'll just call this, that's a love note to MATLAB, right? And so now we've got a string now that's been saved simply by wrapping some text with these single quotes, right? And so we'll be doing some more with Go as well. And so one more note that I want to make about descriptions and descriptive variables is that when creating these variables, notice a couple things. The first thing is that every time we're typing in a variable and a variable name, case sensitive. Okay, so keep that in mind. So big C is different from little c, right? So I can type in C is equal to 87, and that's little c, and over my workspace, I've got a big C and a little c. So you have to be very particular about the case of the variables, okay? The other thing is that your variable name can be a mix of numbers and letters, but it has to always start with a letter, okay? It can't start with a number, okay? But it can be, C754 is equal to 864 divided by big B, okay? That's a legitimate name, okay? So one of the see here is that you've got a lot of latitude in how you name your variables. And that's a really important point because the type of programming that I want you to be doing it's a descriptive variable programming, okay? And so I want you to really think about how you create variable names. And so here's what I mean. So when you've got a problem, okay, we got a cylinder. And so the cylinder width, okay, is 2 meters, right? And the cylinder length, okay, is 2 meters, okay? So if we got this and we want to calculate the volume of this, right? So if we want to calculate the volume of this, then, oops, find my pages here. Then let's clear our command window, clear our workspace. Okay, so the first thing we've got is W equal 2. Okay, I want to suppress that. I've got an L, it's also equal to 2. Okay, so we can't have meters, we're not putting any units on this. But if we want to calculate the volume, okay, we can do that pretty easily by V times pi. Okay, pi is one of our variables that is predefined. Okay, I've got some of that in your cheat sheet. Okay, so it's pi r squared. Okay, so my r is going to be W divided by 2. Okay, and then I'm going to multiply that times that length, right? So I'm going to get 6.2832. Okay, and that's going to be in meters cubed, right? And that's great. But when you see this, if someone saw your programming and they said, all right, V is equal to pi times W over 2 times L, you would say, or at least I would say, hey, that's great. What are we doing here? Right? So I would say this is going to be kind of the typical way of programming. This is how I learned programming. Okay, and the thing is that it doesn't really describe much to whoever's reading the programming, right? They kind of have to say, all right, pi is in here. Why is pi in here? We've got something to do with a circle, right? Because that's where pi is going to come from, right? It's going to be radius divided by this perimeter. Okay, but like what's going on here? What is L? Okay, what is W? Okay, so one way to make this a little bit better is we could do something like the width. Let me get this. So we could say width is equal to 2, and then we could say length is equal to 2, right? So that's a little bit more helpful. And we could say the volume is equal to pi times the width divided by 2 times the length, right? So we're going to get the same answer, right? We got the same number. And I think if you start looking at this, where I've got width, I've got length, I've got volume, now you can start to put that together a little bit more, right? And you probably recognize a pi r squared. Oh, I didn't do that right, did I? That's got to have a squared on it. Sorry about that, guys. Whew. All right, there's my volume. Okay, that makes sense. I'm dividing by 2, right? So it's going to be the same thing. Okay, and so, but still, we're not really sure what's going on, or I'm going to argue that you probably don't really know what's going on here a little bit. So one way to make this even more descriptive is we could do this. So cylinder width is equal to, right? Cylinder length is equal to 2, right? And then cylinder volume is equal to, and now we've got pi times cylinder width, divided by 2 times cylinder length. Okay. All right, let me come back here, cylinder volume. Okay. And now you've got a great description of what's going on. That's really clear. I think you can back that out and understand what's happening. Okay. And we're going to stop right here. Okay. And I want to just show you there's kind of 3 levels that I consider programming to be. And if you consider this communication, all right, the 3rd level is definitely the best in terms of communication, but there's a drawback to it. It's cumbersome. All right. It's really cumbersome to be putting like these long descriptors. So as you're programming, you got to make some decisions as to whether you're going to be, super sparse, somewhere in the middle, or really or kind of long. Okay. And there's trade-offs between them all. I'm going to encourage y'all to be somewhere in the middle. Okay. In the middle of this. And that's going to be for 2 reasons. First is, like I said, when someone else picks up your code again and they want to look at it, it can much better understand what's happening. The second thing is that you get to simplify your comments a lot, okay, by doing this. And then the third thing is that your TAs are probably going to be able to check your work a whole lot better. Okay, it's kind of coming in somewhere in the middle. All right. This is a style of programming that in the developer world was made famous by a guy named Kent Beck. He wrote a book. I think it was in 1997 or 2005 or something. I'm sorry, early 2001. It's called Implementation Patterns. Okay, and essentially just kind of like in the developer world made this a big deal. And here's the 4th reason. We work a lot as engineers with developers and software guys. Okay, and so the better that we can do in understanding how they do things, the better it's going to be in our communication with them as engineers and practicing engineers. All right, so there are practice problems. They're assigned, they're posted on Canvas. Okay. go grab that. Okay. I don't have answers up for those. I will put answers up for those so that you can check your answers. Do everything in the workspace, do everything in your command window, even if you've done programming and scripting like that before. Okay. We'll get to scripts next time as we're doing this. Right. I'm going to stick around for about another 10 minutes after this. I know some of y'all have questions on registration. You have questions on Canvas. If you're having problems on any of this, let me know. The other thing that's up on Canvas are office hours and the office hour schedule. There's also a link that we'll use for office hours. And each of our TAs is going to have 3 hours each week for office hours to help you troubleshoot your code in addition to what we'll be doing in the class period. Okay, so y'all have a good afternoon, or good morning rather, and we'll be seeing you in office hours and other places like that and class on Wednesday. Take care.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.